this video is really short. I just want to give you a summary of all the formulas all in one spot and a pattern of what to do to find all of it. So if we're working with time, maybe because arc length is overly complicated to calculate, or we want to work with time, the tangent vector is r, the first derivative of the position vector r divided by its magnitude. The normal vector is the tangent vector, taking the derivative of that and dividing it by its magnitude. That makes these both unit vectors. And we can find our binormal vector using the cross product of the two vectors we just made. If you're working with S, the arc length, the tangent vector is just the first derivative. We don't need to divide by the magnitude because it's 1. For n, we have two ways we can do it. We could take t prime of s divided by its magnitude, but that's really just the second derivative of r divided by its magnitude, right? The derivative of this is going to be r double prime, so dividing it by its magnitude just gives us that. There are two forms of for doing b here. We could do t cross n, but we've already calculated the magnitude of r double prime. To do the n vector, it might just be easier to do r prime cross r double prime for the binormal vector. Then those are the options we have. So in terms of t, steps to follow: find r prime and use it to find the tangent vector by dividing it by its magnitude. Then we're going to find the derivative of the tangent vector. We'll divide it by its magnitude and use it to find the normal vector. And then we'll use the cross product t cross n to find the binormal vector. Okay. Then you may have different times: t equals t0, t equals t1, t equals t2. However many you need to evaluate these at, do it off of the general form. But if you only need to find the info at one point, save yourself a lot of work. All the way up here, once you find the derivative of the tangent vector, you do not need to find the normal vector for it. You do not need to make a unit vector. Just evaluate at t0. So plug in t0, you'll get t prime of t0. Use that to find the magnitude to find n. So n will be t prime of t0 divided by the magnitude of t prime of t0. These are just numbers. There's no variables left in it because we plugged in a value for t. It makes the work easier, as you'll see. And you can use this to find n, and this n with t, just plugging in t naught into t up here, you can find b also. So it's a lot easier. You can save yourself a lot of steps. You don't need to find n of t. You don't need to find b of t. You can just find the values at those points. That's only if you really need it at one spot. If you need it at more than one spot, you kind of it's best off to just get the general form. And I will show you how to do both. Okay. If you're working in terms of S, the arc length, you have to start off by finding the arc length, of course, unless it's given to you. Sometimes this is easy, sometimes it's not. Sometimes it's not worth it's a pain in the ass to work with. But once you have it, everything kind of falls out pretty easy. R prime of S is just T of S. That should just say T, not T prime. R double prime, we find the second derivative and its magnitude, and we will use that to find both the n vector, dividing the second derivative by its magnitude, and then we will use it to find b by taking the cross product of the first derivative and the second derivative and dividing it by the magnitude of the second derivative. Just a little sneak peek where we're going in 12.5. Curvature is related to R double prime of S, and we'll see that in 12.5. And that's it for this one. Really short, like I was saying. Peace.